Hello, my name is Mario. Welcome to another Software Architecture in Go video. In today's episode, we're going to be discussing how to measure instability in software packages. How to measure software instability. Back in 2002, there was this book written by Robert Martin called Agile Software Development. So Robert Martin is well known for his books. He has written books like Clean Code, Clean Architecture, Agile Manifesto, and some other different articles. He's well known in the industry. During this book, he discussed the concept of instability, and he said that it can be calculated using as the ratio of efferent coupling to total coupling. He even gave us a formula that you can see right here. Now, let's step back a little bit and define what coupling is in the context of software. So coupling is the degree of dependencies or interdependencies between software modules. Specifically for Go, when we are talking about modules, back in the day modules were like in the modular software development kind of context, we're going to be using sort of the same similar concept when discussing Go modules, which I cover in a different video. We'll be leaving the link in the description as well. So every time I say module, I'm referring to Go modules. But inside those Go modules, as you may know already, there are different packages. So the degree of interdependencies between software modules. So what this means is that if there is a package A that depends on B, C, D, and C depends on B and E, there is an interdependency between those different packages. So that's the degree of interdependence that we're calling coupling. So if we go back to the definition that we got from Robert Martin, we can see that there is this thing called efferent coupling, and there are two variables right there. So what does this mean in practice? Well, efferent coupling refers to this CE, which means efferent coupling, and there is this thing called CA, which means afferent coupling. But in reality, what does this mean? Well, efferent refers, and again, all of this is coupling, okay? So it refers to the dependencies that are that we have in the context of A. So A depends on B, C, and D. Now, if we go and look the other way around and say afferent, we say, hey, afferent says that B, C, D, and E depend on A. So it's literally a way to see how the direction where your dependencies are coming from or your dependencies are going to, and this is used for measuring instability in software packages. Again, it's going back to the concept of module that happens to have different packages. So if we translate this formula sort of into something more humanized, you will notice that it's going to be there is an outgoing dependencies, the ratio of that, the addition of the outgoing dependencies and the incoming dependencies, where there is a range. The result of that formula will give you a range between 0 and 1, where 0 indicates it's an stable package or a stable module, and 1 indicates that it's an unstable module or package. Now, how do you do this in Go? Well, there is there are a few different ways. The way I was doing it before, I was literally just doing some like using grep and sort of getting a way to get dependencies manually. But I found this cool tool called SMP Go, which is Software Package Metrics for Go, written by Fernando Daines, and it covers literally all the different metrics that Robert Martin described in his book back in 2002. I will show you how to do it, okay? So let's go and see how this is used in practice. So now let's look at how this works in real life, in practice. The code that I'm going to be using for reference is the one that I've been using in my previous video series, implementing microservices in Go. There is a new tool that I'm going to be using, like I mentioned before. It's called SMP-Go, which is Software Package Metrics in Go, and I install it using this specific instruction. And the way I'm using it is that SMP Go, there are different commands that you can use for generating different outputs and different metrics. And the thing that I want to show you first is that when I'm using dependencies, which indicates this is the dependencies that are being used by my specific Go module, it will say how many are internal, which in the constants will be the standard library, external, which are third-party libraries, and I'm sorry, internal will be the internal packages that I'm using defining my Go module. External will be the third-party packages, and standard will be from the standard library, and it will give you a count, right? So one thing that I want to be showing you is I want to show you how this displays in or rather how this is the values that we're getting here compared to the metrics that we're going to be using when we're using efferent coupling and afferent coupling, how those things are going to be used for making decisions depending on how unstable or unstable our packages are. Okay, so right here we can see that CLI, for example, has an internal dependency that will be referencing to the OpenAPI 3 package that we define. It has 9 external, which are the third-party API, the third-party packages, and you sort of get the idea, right? So there are different ways that this tool is listing all those dependencies. If we go back and generate the one for instability, it will actually generate a similar output. So let's wait a little bit so it's generated. And this is the one that I want to show you, and this is the important one because when we were discussing about the efferent coupling and afferent coupling, we were saying, hey, depending on the ratio that these values have, we're going to be determining how unstable or stable our package is. And you need to think of in the context of how easy or difficult it is to make changes to this package. Now, you need to take this with a grain of salt because it actually depends on the package itself. For example, so all the main packages that we have right here will have a high efferent value, and the reason being is that efferent indicates the dependencies that this package has. Obviously, because in the context of the format of the guidelines that we're following, CMD or the binary that lives under CMD is the main package, therefore is importing all the different packages that we are using in our repository and our project. It's sort of like orchestrating all the dependencies and linking all of them in the same binary. So the value of that specific package will be high and will be unstable, or the instability will be high, and that is expected and that is okay. You shouldn't be worried about it. But there is one thing that I want to show you. In the context of packages that are being used by other packages, we need to think of, hey, if I have this CMD internal that is at the moment the afferent, which means, hey, who is using this package? It means there are 4 different packages that are using it, and is using 3 other packages. What this means is that if I want to make a change to this internal package, it's going to be more difficult to make it because there are other packages using it. So to rephrase it, if I want to, let's say, change the API that I have defined in the CMD internal package, what is going to happen is that if I break that API, I need to go and modify, in this case, perhaps 4 other different packages. And that's why the instability it's indicated right here. So it's sort of like depending on how stable or unstable it is, it's sort of the other way around it. If you see it that way, if it's stable, the closest to a stable being is that if I make a change to that package, it means that perhaps some other packages that depend on that one will need to be changed as well. And the other way around is that, for example, nobody's using CMD CLI, so this one is considered unstable. But if I see it that way, so I can literally just tear it down and rewrite it, and nobody cares outside of the package itself. So it's a way to measure how the packages can evolve from time to time, and it's something to keep an eye out when trying to modify and make changes. And that's why important that as a software architect, you need to keep an eye out and think of, hey, if I'm making or adding too many dependencies to this specific package, there is a lot of coupling, perhaps we should be thinking this out, and then maybe we should be changing the way it is. Now, another example I want to give you is in the service. The service right here, if you notice, although it's using values or types that are coming from or via dependency injection, is sort of like not stable or unstable. It's sort of half and half, because it's literally not referencing anything outside of the package itself. It's using type interfaces. or rather interface types. So that is a way that this package itself can evolve without having any other packages being touched. Again, in the end, because everything is being compiled and built as a binary in the CMD package, or the CMD whatever main package, it most likely is going to change. So it's something to keep in mind. So let's jump into the conclusions, and I will share with you my final thoughts. So we covered how to measure instability using software metrics, or using software package metrics. The idea of this is that you can keep an eye out when making changes to the packages that you have. With the idea is that eventually, if there are too many dependencies or too much coupling, you may have problems modifying that package in the future. Like I said, an stable package means that everybody else is using it, so everybody depends on that package. So modifying that package could break other packages without, thinking that in advance. It's a way to sort of like measure the level of effort when you're trying to modify something that you have. Let's say you're trying to rewrite maybe a different package that is in, or rather you're trying to modify a type that is in the domain package, and that one has a lot of dependencies, so it's being used by different layers or packages. If I go and modify that one, which is considered stable, it's going to be more difficult, and it's going to take a little bit longer than going and modifying one that is considered unstable, because the unstable one doesn't have any dependencies, or nobody is depending on that one. So it's another way to consider when building projects, that there is a way to measure the way that we have the different packages interacting with each other in the same Go module that we built before. So this is the beginning of different ways to measure software packages. I will be covering the other ones, like abstractness and distance domain. Those will be covered in different videos. So again, as usual, thank you for watching, and if you have any questions or any comments, please let me know. If you want me to cover any other software architecture based topics using Go, again, leave a comment and I will talk to you. I will answer the comment and I will talk to you next time. So take care, have a good one, see you next time.